It's your friendly math tutor, Miss C here, and today we are adding rational expressions. So what makes this a rational expression? There's x's in the denominator. That's it. So anytime we add fractions, we have to have a common denominator, and I can see that we do not. So let's see what we have in common, and then we will start to get a common denominator as our first step. So I'm noticing in this first fraction in the denominator of x minus 2, I don't see that on this right side denominator. So I know I'm going to need to get an x minus 2 on that side. I see an x plus 2 here. I also see an x plus 2 here. So that's what's in common. But I also have this x plus 1. So we know that we are going to have to do things to both sides or to both fractions in this expression to get a common denominator. So I'm going to start on the left side. So what I need on the left side is this x plus 1. So I'm going to multiply this side by x plus 1. Okay, and what I do to the denominator of a fraction, I do to the numerator. So I'm putting x plus 1 here. Just as a reminder, this is an equivalent fraction. X plus 1 divided by x plus 1 is 1. I haven't changed the value, I've just changed how it looks. Now, one last thing. I'm multiplying all of x minus 3 by x plus 1. I need to put a parenthesis around this. Otherwise, it looks like I'm just multiplying x plus 1 by the x and not by the negative 3. Okay. My next fraction, I noticed that x minus 2 was the thing that was missing, so I'm going to do the same thing that I did on the other side, subtracting x minus 2, or I'm multiplying x minus 2 on that side, and what I do to the denominator, I do to the numerator, creating an equivalent fraction once again, and to make sure I'm multiplying by the whole binomial in the numerator, I'm putting parentheses. So I'm going to rewrite this the long way. So I'm going to show very clearly that this is what I have on my left side fraction, and this is what I have on my right side fraction. Now, once you know what you're doing here, you can skip this step, but I want to show you that we do have a common denominator. We have all three binomials in the denominator. It does not matter what order we have. Okay, so I'm going to come down, and as my next step, and by the way, this would have been the step that I would have taken if I were doing this, not making a video, I would have just combined the denominators straight away because I knew they were the same. And then you can add the numerators. So instead of just rewriting the numerators, I'm going to go ahead and I'm going to distribute. So end up with x squared minus 3x, right? I'm foiling, if you like that method, plus x minus 3. Remember, plus x is the same thing as minus x. I'm going to do that. Oh, I grabbed a highlighter. Let me try that again. I'm going to do the same thing on this side. I'm distributing, and maybe if I go to the numerator, plus x squared minus 2x plus 3x minus 6. Okay, so I'm just distributing this. And now we're going to combine like terms. So I'm going to look for all of my x squareds here, and I notice that I have two of them. Okay, the x's, grab a different color here. I see that I have negative 3x plus x. I'm going to write over here so we can see what we're doing. And I also have 3x minus 2x. So that's positive x. So I'm left with just negative 1x or negative x. And then I also have my constant. So I've got negative 6 and negative 3. It's negative 9. So I'm going to go ahead and rewrite this. Okay, now what we want to do is we want to see if there's any way we can combine, we can factor the numerator. So I'm looking at the factors of 2x squared, as we can use 2 times 1, right? And 9 is really 3 times 3, or 9 and 1. But the problem with 9 or 1 is that these guys have to connect somehow. I don't think there's any way to factor this. I think this is as simplified as it gets. If you absolutely weren't sure if you could factor the numerator, you could always pop it into the quadratic formula and see if you get whole numbers out. I am 99.9% sure you're not going to get a whole number out. So we're just going to leave our answer like this. And that is how you add rational expressions. Till next time, remember, you've got this.